Hi, we are Mrs. Doubthired 2, straight to VHS. I'm Betsy, and the team is me, Christian, Ignacio, Srilaya, and Jeremy. So a little background info. This is a project that builds on a previous project where me and Christian made a machine learning project where we generated pictures of software engineers using Hired's data set of candidate software engineer profiles. We called them Betsy's Boys, the tech team of the future. They were hideous, frankly. Everyone delighted in finding, who's who, finding themselves in there. I, know who's who. I sort everyone. And actually, if you're interested in learning more about the Betsy's Boys, Jeremy made a little Betsy's Boys NFT auction website where you can buy your own NFT Betsy's Boy. More on that if you ask me later. So a little bit of background information out again. It's a generative adversarial network. It's basically all you need to know for the purposes of this is it's going to generate novel pictures, in this case, from a data set of real pictures. So these, as you could see, these were the input data of last time. We didn't have time to regularize the data, so that's kind of why we got these weird looking people. As you could see, yeah, they look like monsters. That's because of the white space. It's not uniform and clean, etc. So even regardless of that, the monstrous weirdness of them, that's due to the irregularity, something else stands out from last time that we talked about in the last demo. The data set, the original data set, included people of color and women. It actually did. The gray is the real behind, the red is the fakes. Whereas the fakes do not include anyone except for lightly colored males. I'll get into why this happens a little bit more later, but we'll see what I have time for. So we wanted to keep talking about this. We wanted to keep, sorry, I have to do not disturb. Oh, gosh. Wanted to keep building on this. So we had some new members added to the team, Srilaya, Jeremy, Ignacio, and we had some goals. We wanted to improve the realisticness and maybe also the homogeneity that I was just discussing of the results by pre-processing the data. We would use an ML model to recognize faces and eliminate all the pictures that don't contain real faces. We were also going to, use that facial recognition model to crop in on faces so that the input data is more uniform. We also wanted to run the model on other professions, not just software engineers, out of curiosity. And we wanted to enforce gender parity in the results by using bias mitigating data augmentation techniques. We wanted to use resampling to enforce 50-50 representation of gender in the results. And moreover, we really wanted to understand how lessons learned from the ML feedback loop and bias mitigation techniques and the lessons from the bias mitigation techniques apply to society at large, specifically in hiring. So what professions we generated pictures for, I'm not going to show them all because we don't have time, but we did sales, marketing, data science, DevOps, software engineering. These are real sales people from Hired. These are ones made by our model. They look very lifelike, as you could see, kind of creepy, or some of them kind of weird, but still pretty good. These are real marketing people. I'm going to breeze through, skipping ahead for brevity. Now, here we are. These are the software engineers. I'm going to give everyone the slides. You could look at the other professions later. These are our real software engineers from Hired, okay? So yeah, as you can see, the data is still, mostly men. I think it's like 80-20, I forget right now. This is the real input data. This is what gets generated. As you can see, it's because the pictures are more realistic and the model got, I think, a lot smarter from that, it stopped erring on the side of the lowest common denominator all the time to fool the discriminator network. Because of that, there is a little bit more, there's more femme-looking people in the results, like as opposed to zero, and more dark people in the results as opposed to close to zero. And I think that's interesting that was a big improvement. It kind of is a lesson in how, cutting corners in ML will lead to problems like Betsy's Boys. So what about this gender imbalance? More about that. Among the software engineers, for instance, here's something, just a general thing. There's bias in a training set. When there's bias in a training set, it can influence many machine learning algorithms, leading some to ignore the minority class entirely, as we saw in Mrs. Dowd Hired Part 1, Betsy's Boys. If we want to see parity in the results, we can alter the input data through random resampling. This is just like a thing in ML. That can be a combination of undersampling, deleting examples from the majority class, in our case male, and oversampling, duplicating examples from the minority class, female. We use this technique to deliberately make our input data set be 50-50 male and female so that we could see that in the results. So we did that here, and then here we oversampled. This is the results of the oversample. Everyone should look at this later. It's cool, but I don't have time because I want to get to the bigger picture. So how do machine learning models work? This is kind of going back to this bigger picture lessons thing that we were all talking about throughout this. Machine learning models heavily depend on historical data for future predictions. But there are two problems that I can think of right away or right now associated with this. Number one, we pretend that we're predicting the future when really we're not just predicting it, we're influencing it. I didn't actually think of this. I learned this from Fairness in ML, a book that I cite later. The fact that we frame a lot of machine learning projects as prediction tasks is the issue itself, because what are we predicting? We're predicting what decision would be made by past human decision makers. You just will be, at best, you'll just be reproducing the bias of the past human decision makers. Because whether or not we let someone, in our case, onto our hired platform or bubble them up and to the most recommended candidates also influences if they get the job. So we can't actually test if we were right to reject someone because they never got a chance to show us if we were right because we didn't let them on the platform. And so we also took away their some of the likelihood of them getting a job by not letting them on Hired's platform. So we're not really just predicting, we're really influencing when we use ML this way. Number two, the historical data that we're using is not based on the objective truth of who's good enough to get a job or who is smart enough. The data reflects historical discrimination. If something has been historically documented to be the result of discrimination, then we should, I didn't end a sentence there. Then we should probably not use that to make decisions going forward. But we are using this data to feed our models forward into a feedback loop. This is happening everywhere in the world where often we are using that data. And that does happen everywhere in the world where machine learning is used, including in law enforcement, or whether or not we give someone a bank loan. This happens in many cases. So that leads me to a third problem. The hidden nature of those problems raises a third problem. The fact that it's ML suggests that these results are neutral. In her book, Ruha Benjamin argues that this automation has the potential to hide, speed up, and deepen discrimination while appearing neutral and even benevolent when compared to the racism of the past. Please read more on this later. Got to keep going. I want to get to the main point. This is like my bigger picture thing, okay? We know in ML that oversampling and other techniques for improving fairness are real things that are used to combat the sort of situation where data is unevenly distributed across groups to avoid creating a model that favors the majority group in its results. We know that we need to oversample minority data to make up for the imbalance in our input data so as not to perpetuate the problem going forward, lest we end up with a model that increasingly ignores or neglects minority classes in an ongoing feedback loop. As we saw with Betsy's Boys, as you can see in many other cases. The fact that we need these strategies in ML models demonstrates how we need the equivalent strategy in the meta feedback loop that is the entire hiring industry, as well as all the other feedback loops that determine society and social class, etc. Basically, I think, we need affirmative action on all fronts. So ML, more about this metaphor. The toggle, this leads me to my bigger thing about Hired. I'm so proud. The toggle for promoting underrepresented candidates is a huge deal for this reason. It makes us very proud to work at Hired. Here's hoping this project and these musings help all of us at Hired continue to change the way people find and hire talent. Here's some more interesting information if you guys want to look at this later. And here's a little bit about our stack. We had 2 machine learning models, a bunch of other scripts, and some links and resources. Thank you so much. Love, Betsy, Christian, Srilaya, Ignacio, and Jeremy.